So one of the cool features that MATLAB has is basic curve fitting, and that's what I'm going to show you today. So let's just create a file call it curve fitting. I'm going to call it basic curve fitting. Okay. So in order to curve fit, you need some data in your hand, and because right now I don't have, I'm just gonna create one. I'm just gonna create the data, and first I'm gonna take a perfect quadratic equation and show you how curve fitting works. So let me take x between maybe -20 to +20, and then my f is gonna be some perfect quadratic. So x squared minus 5x plus 6. I guess this is a perfect quadratic. Okay, so this expression is definitely like it won't work. It will give you error. You can see that here you get an error. The problem is, you know that your x value it's basically a row vector and it contains values between -20 and 20. So the size of x is 1 cross 100 because we know linear space creates 100 different numbers or different cells. So my x size is 1 cross 100 and f is basically right now just holding a function. So if you want to use one of those x and calculate f, this is how you would write. But since I need to calculate this f at each x and there are 100x, so for that kind of operation, what you need is element-wise operation. So element-wise operation can be performed using this dot. So all you have to do is before this mathematical sign, you put a dot or a period. That's it. And that's how MATLAB knows that for each x, it needs to calculate f. Okay. And then let me plot that number. Okay, so I have this quadratic. To fit this data, what you can do is you can just go to basic fitting. It opens up a new window. It might take some time. Okay, so we have this window open. Click on what kind of curve do you want. Let's just say I want quadratic curve. I'm just gonna check off this one. Come on, baby. Okay, sometimes MATLAB misbehaves. Okay, check it off. Okay, and then expand this fit results. Make sure that the equation and maybe r square, these are checked off so that you can see the equation in your curve. So you see, if I check it, equation goes away. If I check it off, equation, you can see the equation now. Anyways, so this is how we basically fit the data. You can plot that, and then you can go to tools, basic fitting, and then select the kind of equation that you want to fit, and then you can click on it if you want to see the equation here. So you can see that the MATLAB fits this data and creates an equation x squared minus 5x plus 6, which is basically our equation. So it's r squared is 1, that means 100% best fitting. Okay, so what I'm gonna do now is I'm gonna go to I'm gonna like make some changes here along this curve. I'm gonna maybe take this data and change it a little bit so that the data offsets, rather than being on this line, I'm gonna make this data to be here, and then somewhere here I'm gonna change the data to be here or maybe here. So I'm gonna choose some random like 10 to 20 points in this curve and then manipulate or alter those data points. Let me show you how I can do that. I'm gonna create a loop for I between 1 to, let's just say I'm gonna change 20 points. Okay, and first I need to select a cell in F And how do I do that? Well, I can take a random number and generate a random number, and since I want to select cells between 1 and 100, I can multiply by 100, and this whole thing rand multiplied by 100, it will most likely give me a fractional number, and we know that the cell number has to be an integer. So what I'm gonna do is I'm gonna round it off. Nice, this will give me an integer, and that's how I'm gonna select a random cell in this F dataset. Okay, and then change the value of that cell to be something else. So F1 comma cell, this is like the current value, or and then I want to change it to, let's just say we multiply or add, we add some random negative number, not random negative, but rand and will generate either positive or negative number. So that's what we are going to add or subtract. Okay, that's it. So it will basically pick a cell, let's just say 15th number cell, we pick in this F, and then in that 15th number cell, whatever value is already available in that, we are gonna make this much of change. That's it. Okay, perfect. And after changing this, let me plot that. Should I plot in different window? No, I'm gonna plot in the same window so that we can see the difference. For that, I'm gonna need hold on and plot x against F. That's it. Run it. Okay, I have something in this window. You can see that there are some changes, but the change is really little, like very little. You can see here, you see, come on, wait, you see, this is our perfect equation, and this is the amount of change that this particular loop brought in this app. Anyways, this time I'm gonna make larger changes. Let me do that. Okay, so instead of choosing rand and negative, what I can do is I can multiply it with maybe some 2, and this should increase the, also let me clear of my figure window, also some, oops, I should have cleared figure window. Come on, nice. Okay, run again. Nice. Now you can see that the data that we alter using this loop is greater, and you can see the difference like here. Maybe I can increase the change in data a little bit more by 5. CLF, CLC, and clear, and run. Okay, now we can see the large changes in data. So this is basically like 20 data points are changed by a small amount. And now what I'm gonna do is I'm gonna data fit my data point to. So I'm gonna go to tools, basic fitting, and then select the data point, data 2. That's what I wanna fit. I wanna fit quadratic. Make sure I want to see the equation in r square. So see, for my second data point, after changing the this f value, the equation has become this, which is very close to the actual equation, which is x square minus 5x plus 6. You can see. So yeah, this is how, if you have data, you can plot it and basically fit that, find an equation, and you can also see r square, how closely that data fits to your equation.